All right, good afternoon, everyone. We are going to be doing an exercise today. Get a little bit of practice with for loops. Before we do that, I wanted to let everyone know given the results of the midterm, specifically the vocarium portion, I think what I'm going to do is, so I don't want us to lose hope. And many of us did not do so well on the vocarium portion of the midterm. So what I'll do for the final, I will allow the higher, so there'll be a vocarium portion on the final as well. So whatever you make on either portion, the highest of the two scores will be applied twice. So for example, if you made 100 this time, then you'll get 100. Well, not the other way around. Let me not say it's the other way around. That'll stand alone. But for the final, if you make a higher score than you did this time, so if you made a 0 and you make an 80 on the final for vocarium, then that 80 will be applied to your vocarium score for the midterm. All right, so with that, so don't lose hope. I don't want anyone quitting and giving up. Don't give up. Keep trying. You can get it. But today, we're going to do an exercise. So if you have your laptops with you, we are going to do an exercise on for loops. Now, remember the homework assignment where we had to calculate the Fibonacci number, but we did it using a formula. It turns out there's another way to do it. It's actually faster, and that's using iteration. Believe it or not, it actually is faster because of the types of instructions the CPU are doing. It can do those types of instructions faster. So what I would like you to do is write a function that will accept a number. So for example, n, where that number represents the term you want to find. So I want to find the 10th term, for example, the 10th term of the Fibonacci sequence. And what your function should do, it should use iteration to produce the result. So you give me n, I calculate the nth term, and I give that back. Let's click this. If you aren't familiar with how the Fibonacci sequence works. I know in the last assignment, we just had a formula and we implemented the formula and we were done, but it's quite interesting how that works. And it's actually a really famous sequence. The Fibonacci sequence always starts with either a 0 and a 1 or a 1 and a 1. So depending on which two numbers you start with, of course, the rest of the terms will differ, but they always start with one of those two combinations of numbers. So that's fixed. There's no calculating to that. The first two numbers will always be either 0 and 1 or 1 and 1. But after that, starting from the third term, you always calculate the current term by adding the previous two terms together. So this is a result of adding up term 1 and 2. This is a result of adding these previous two terms together. So 2 is 1 plus 1. 3 is 2 plus 1. 5 is 3 plus 2. 8 is 5 plus 3. And that just continues forever. Right. So what I would like you to do is implement that logic using some type of iteration. Oops. Write a function that will take this idea that's capable of iteratively calculating some terms. So let's say I want this one here. So 1, 2, 3, 4, 5, 6, 7, 8. If I give you an 8, you should give me back 13. You should be able to calculate the 13th term. Not using the formula, but using iteration. The other thing we want to do is write another function. And what this function should do, it should prompt the user to enter 10 whole numbers and then return the average of all of those numbers. Right, so again, you're going to use iteration to do this. Don't write 10 scan statements. Use a loop. Scan something, do something with it, etc. So your second function should prompt the user to enter 10 numbers, and then it should return the average of those 10 numbers. If you go here, these are just lots of 59 exercises, different exercises that you can do to practice for loops, and it also includes their solutions. So for those of you that want to practice, you can go to this link here, and this second exercise is a variation of one of those on this page. But you can see there are others. And if let's say you want to try this one and you get stumped, you can just click that button and you can actually look at the solution. They show you the code, how to do it. And finally, once you're done, once you've written those two functions, test your functions. How do you do it? Well, write a main function and call those functions and see if they work correctly. Any questions? All right, you can begin. And I'm here if you have questions. We want to talk about that one a little bit together. All right. So let's think about, well, first of all, we know we want to write a function, right? So let's start with the basics. Let's get the outline of the function taken care of. Now, looking at the description here, what do we know about our function? We know our function, we know functions have a couple of pieces that we have to fill in when we're defining functions, right? What do they return? What are they called? What are the parameters? And then, of course, the function body. So looking at the description here, what might we think we would want to put for those pieces? All right, so if we were to, let's start filling this in. What is my function going to return? Is it going to return anything? An in, a whole number, right? It's going to be one of the Fibonacci terms. It's always a whole number. And we'll call it, we'll just say fib number. Give it a name. Are there any parameters to this function? Do we need to give it any information for it to be able to run correctly? Which term I want. So I need to pass that information in. What is that going to be? It's going to be an n. So we'll make a placeholder here. We'll just call it n because I want the nth term. And here we'll return something, right? We'll just return 0 for now. We do need to return something. So we have a stub. Now, if I were to run this, if I were to compile it, it would compile, right? So no problem. It doesn't do anything, but at least it compiled. I don't have any errors. Now let's think about the Fibonacci sequence. And let's start by writing it. Let's say we start at 0 and 1. So those are my first two numbers. And the next one we have 2, and then 3, and then 5, and then 8, 13. All right, so let's take this and we'll kind of use this to try to figure out what we want to do. So somehow we want to iteratively calculate each of these numbers. Now, the first two are always fixed, right? I don't have to do anything for the first two, do I? I already know what they're going to be. So maybe, let's suppose that n asked me for one of these two numbers. What can I do? If I want the first term or the second term. Oh, what would that look like? So let's ask another question. Let's suppose that whoever's calling this function wants to know the first term in the Fibonacci sequence. How do you know that's what they want? Like in here, like by the time you get here, what's that? Well, that's what they want you to give them back. They're going to say, hey, I want the first term. Like, how do they tell you that? They're going to tell you that by calling this function. So let's take a look at for example. Okay, so I'm going to use it like this, right? Fib num, and then let's say, there we go. So that means I want the first term. So that's great, but now I'm here, I'm defining this as if they had done that, right? So based on that information, in here, between line 4 and 10, what type of indication do I have in here that they typed a 1 in? How do I know they want the first term? Where's the 1 going to be? Let me ask that. It's going to be an n. So how do I know they want the first term? I look at n, right? So n tells us what they want. Now that we know where to look, what could our if statement look like? What might the if statement look like that we need to write if they want the first term back? Because we don't know what they're going to ask for. They could ask for anything. If they happen to ask for the first term, we know what we can give them back. But how do we say that? How do we say, if they ask for the first term, I'm just going to give you back a 0? Because I don't even need to calculate that. If what? Okay, there you go. If n equals 1, return 0. Very good. We're done. We don't even need to do anything. If you want the first term, I'm just going to give you back a 0. I don't need to do anything else. Right? What about the next one? Can we do the same thing for 2? All right. So if n equals 2, return 1. Right? Because that's what we said the first 2 terms are. There goes the first 2 terms right here, 1 and 2. All right. What about the next one? Can we do it for the next one? We could. And we could do it for the next one, but now I don't know what they're going to ask me for. So how many if statements do I want to write? So you could write it. So the question was, should this second statement be an else if statement? Should we make it exclusive? And we could. In this case, it's not necessary because of this return statement right here. Because if this is true, what am I going to do? I'm going to exit the function, right? So I'm not even going to look at this one because I'm just going to exit right away. If we did not have a return statement there, however, then yes, you would probably want, well, let's take another step back. If you consider the fact that all of these values are going to be unique, right? Then, or all of these are going to be unique, right? You're only going to ask me for 1 term. Then in that case, it really doesn't matter if you evaluate all of them. Only one of them is going to be true. Performance-wise, if you have a lot of if statements, like 1,000 if statements, it might be useful not to run 999 of them, right? But because of those reasons, it's probably not necessary to do it. Really, when that's important is, again, for performance, or when it's possible that you could actually have one value that triggers multiple true statements, would make multiple things true. In this case, only one of these are ever going to be true at a time. All right, so of course we could continue writing if statements, but that's probably not what we want to do, right? It's probably not how we want to calculate this. So let's think about how we could calculate the third term. So we already know what it is, but how can we calculate that term, right? What would that look like in code if I wanted to calculate this number here? Go ahead. It'd be number 1 plus number 2. So what do we need to do first? Like, to be able to make that calculation, we probably need somewhere to put those values, right? So let's go ahead and just make we'll make a number 1. We'll just call it number 1, and we'll set it to 0 right now because that's going to be the first number. And we'll go int number 2 equals 1, and then And let's just say current term equals N1 plus N2, right? And there we go. So now I have calculated the third term. So if you want the third term, at least we know how to calculate it, right? How would we calculate the next term? Now I want to get the fourth term now. Okay, so we could do current term plus N2, but where do I put it? Where am I going to put it? I can calculate it here. And I suppose if all we want to do is calculate it, it's not necessarily a problem yet. So let's hold off on that thought. So this is going to get us the third term, right? And we're actually going to save it in a variable. This will get us the fourth term, but we don't have anything to save it in. What do I do when I want the fifth term? Well, I know the third one, but how do I say what the fourth one is? How do I know that? Huh? I suppose we could just calculate it again. So let's see. The third term was this. And then the next term was this, right? So I guess I could do this. So I suppose we could do that to calculate the fifth term, but this is kind of getting out of hand, isn't it? So we need to make new variables. What's that? Or I could do what? We could make new variables, but then we're kind of at the same dilemma, right? How many new variables do I make? Do I make 90? Well, there are lots of answers, right? Well, that's true. So I could make 70 variables. I think that's about what the limit is. That's kind of painful though, right? We probably don't want to make 70 variables. And this is one use case. Let's take another circumstance where you may have more than 70 answers. You don't really want to make thousands of variables if you don't have to.
Three, right? You get one, and then you run a loop that takes the first at the second and puts it in the third.
So maybe we could reuse some of these variables, couldn't we? That's a good idea. What if we just reuse what we have already? So maybe instead of current term, let's just call this one, let's just call it N3. So we have 3, or we'll leave it like that. We'll just say nth term. We'll call it nth term because that's what we're looking for. So maybe we write a loop. What could our loop look like? We know we need a loop counter variable, right? Maybe we do, let's say I equal, we'll start it the regular way and we'll kind of do some trial and error and see what works and what doesn't work. So I is less than, I don't know where I stop, and then I plus plus. So the loop could look something like this. Something has to go right here for this question mark. But for the time being, what could we do? Well, we know that we can always just do N1, we'll do nth term equals N1 plus N2. So that's kind of done, right? We don't need that math anymore. We'll do that inside of our loop. And now we need to shift values. So we're going to reuse these variables to get ready for the next, let's call it rotation, right? So if I do this, then I have the first fib number here. I got the second fib number here. And this is the one I just calculated. If I want to be able to calculate this one, these two need to be in these first two variables then, right? So how do I move those into those first two variables to get ready for the next calculation? You're on the right track. I don't know how to say that. Like that? I don't know how to say that. You're on the right track.
N1 is equal to N2.
There you go. Very good. So we just take whatever, and you have to do it in this order. So you don't, because once you do this, you erase what was in N1, it goes away. So if you do N2 first, you lose that value, right? So basically what we did was we took these two values and we shifted them this way, right? I took this one and I copied it up, and I took this one and I copied it up. And then next time I loop, I'm just going to add these two numbers again, and this is always going to be correct. Right, so that's great. So we've got the logic now, but we're still missing the loop part. So you got to help me here. This might not be 0 either, right? What does this need to look like? So I need some starting value for I, and I need to stop it at the appropriate time so that this does the correct number of calculations, so that when I'm done, I return the correct Fibonacci number. Okay, so let's say I is less than n, because that's the term I want, right? And then where do I start? What's my starting value? It could be 0. Let's make it 0. All right. And do we want to test it and see what happens? Well, how does the loop work? So let's go through this loop here. What do we think is going to happen? So I is going to be 0. We're going to test this. Is 0, let's say n is 3. Let's pretend n is 3. Because for 1 and 2, we're not even going to get this far. We're just going to exit the function, right? So if n is 3, is 0 less than 3? It is less than 3. Very good. So we're going to do this calculation. So this equals 0 plus 1. Now this is what I want to get back. So right now that's the number 2. Then n1 is going to equal that. N2 is going to equal that. And we're going to go back to the top of the loop. So I plus plus, now I is 1. Is 1 less than 3? Yes, it is. Okay, so this now is going to equal that plus that. So now nth term is 3. And we'll just change these two. So we have 2 and 3. So this is 2. This is 2 now. That's 3. And this is a 3 in it. And we'll go back to the top. So I is 2, I plus plus, is 2 less than 3. Okay, so let's go do this again. So this was 3. Now it's going to be 2. What's that? Well, it's not thinking anything. It's doing exactly what we're telling it to do. So right here, if n is 1, we'll never get past this line. If n is 1, we're just going to exit on line 7. If n is 2, we're going to exit on line 8. That's right. We don't want it. We don't want this to loop 3 times, do we? So how do we modify the loop so it doesn't loop 3 times? Okay, we could do that. if we could leave that the same, we could say n minus 2. And let's see what happens now. So 3 minus 2 is what? So that would be 0. It would do the calculation, then it would change to 1 and it would exit. Okay. So why don't we try it and see? Let's say let's try it for 1, 2, and 3. And we'll compile it and we'll run it and let's see what happens. We should get 0, 1, and 2. Oh, 0, 1, and 1. That's right, because 0 plus 1 is 1. Hey, very good. So it worked. Now, what if we try it for, let's try the next one. What do we think will happen? Do we think it's going to behave correctly? Here's the code. Do we think it's going to behave correctly? Why don't we try it and see? We don't have to guess, right? We can just look, we can just run it and see. And oh, look at that. And let's try it with 5. Again, and we should get 2 plus 1. Very good. So it looks like we have found a solution. Now, let's go back here. Nice job, everyone. So as far as this goes, right? So we've learned about for loops this way, and we've seen how for this example, we're really only using this to control how many times we iterate. I'm not using n down here like we did in the PowerPoint, but you've seen how this is flexible, right? So this is one option. Is we could have done this. What else could we have done? We could have modified this differently, right? We could have also just had a different starting value. Instead of starting at 0, we could have started at 2. Right, so 2 is less than 3. And if you think about it, we already have the first 2 terms, right? So we could start at 2. 2 is less than 3. It'll do this, increment it to 3, and then stop. 4, same thing, right? Either one works. So I guess the point is that this is flexible. This doesn't always look the same, right? This part we modify to suit our needs. Right, so for us, we just needed it to always iterate the appropriate number of times based on whatever n was. And there are different ways we could do that. We could have adjusted this value, or we could have adjusted the starting value to get there. Does that make sense to everyone? All right, great. Then let us do work on the next one then. So the next one should be a little more straightforward, right? We're just going to prompt the user to give you some numbers. And then what you want to do is return the average of those numbers. And we want to use a loop to do that. You also want to write a function. All right, so let's think about this function. If you looking at this description here, do you think this function is going to need to return anything? Okay, what is it going to need to return? What data type? Probably a double, right? Because an average could be a floating point number. So we're going to need to return a double. Are you going to need any parameters? Do you need any input from the user when they call the function? No, right? Because right here we said we're going to prompt them. So we're going to use scanf. So you don't have to pass the number in as a parameter. You just call the function. The function's going to use scanf, and when it's done, it's going to return a value to you. So this function has no parameters, and it returns a double. Very good. let's take a look at this one together. We want to do, I'd like to try to get through some of this so y'all have something to look at. So here's our next function. We're going to return a double, right? We'll just say return average. We don't have any parameters. So this is going to be blank. We do need the parentheses, but it's going to be blank. And for now, we'll just return 0. All right. So we know we need to calculate the average of a set of numbers. So we're calculating some sum. What might we need to do that? What are some tools, C language tools that we might need to get that done? We have that, but okay, we have that. Okay, so let's do that print statement. Print, please enter 10 numbers. We won't worry about any error checking. We'll just do that. And then what are we going to do? We need to actually save the numbers they give us, right? So let's try to save one. We're going to use scanf. They're going to give us a number, and I'm going to put it. Oh, where am I going to put it? That's right. I don't have a variable yet, so I need to put it somewhere. So why don't we make a variable for that? Int, we'll just call it number. And we'll put that number right here. So now I have one number. What's my next step? We could do it again, I suppose. But again, remember, we don't want to do this 10 times. I only want to use this one time, and I want to use some type of iteration mechanic to repeat these instructions for me so I don't have to type it in multiple times. So this is going to scan one number. If I want to call this 10 different times, what could I do? I could write a for loop. Very good. What might that for loop look like? We'll do our typical start. I equals question mark. I less than question mark. I plus plus. So what goes in these question marks? What do I replace these question marks with? Yeah, so how do I set this for loop up to make sure that it iterates 10 times? 0 and 10. There are lots of different things we could do. I could do 1 and 11. I could do 10 and 20. It really doesn't matter. I just want to make sure it runs 10 times. So I have some starting value, some ending value, and I'm modifying I so that it runs exactly the number of times I want it to run. So this is going to do this 10 times. It's going to get 10 numbers. And every time it runs, it's going to scan something I type into the keyboard and to save it right there. Are we done? We've got to add them together. How do we do that? Are we missing something? We need another variable that we can use to save those values, right? So let's go ahead and create a value. We'll call it sum. And we'll just initialize it to 0 for now, because initially it's not going to have any value. And now that we have this extra variable, what can we do inside here once we scan and save that value? Huh? Oh, okay. How do I do it? Well, we already have the 0 here. Okay. There we go. So we're just going to add it to some. And once we get done with this loop, we should have all 10 numbers added up into this variable. And then what can we do? We're just going to return. This is straightforward, right? It's divided by, we already know it's 10 because we scanned 10 numbers. One of these needs to be a double or it won't do. It's going to do integer division if it's not. So we'll do the sum divided by 10.0. And that should give us back an average. So let's try it. Let's see, what did we call that? We called it return average. So print. And we'll do return average. Is that what I called it? All right. All right, so no parameters. So I don't have to type anything in there. It's going to return a double. So there I'm going to take that and insert it into that string. And let's just see what happens. So type in 10 number with an S. So let's just type in 10 ones. 1, 1, hey. 3, 4, 5, 6, 7, 8, 9, 10. And okay, well, that's not terrible. Let's try something a little harder. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And sure, perfect. So 5 of these should give back 1.5. So very nice. Nicely done. Now, now that we have completed those 2 tasks, we have one final thing to do. I want you in here. So you see how I called the Fibonacci number function 5 times, but I did it manually, right? How can I use a for loop to do this? Call it 10 times, but every time I call it, I want to pass it a different value, at least the numbers 1 through 10. So I want to call it 10 times. And the first time I call it, I want to ask for number 1. So here I did 1 through 5, but I did it manually, right? How do we call it 10 times, but pass it 10 distinct values from right here? Help me write that loop. Let's write the loop. So we know we need a loop, right? So let's make our loop counter variable. And we'll go ahead and start writing our loop syntax. 1 equals question mark, or I equals question mark, I less than question mark, and I plus plus. And what am I going to do 10 times? This? Am I going to do all these instructions 10 times? Huh? Okay, it's hard to hear. Okay, what term could I use? You mean like a variable? Do I maybe already have one I could use? Or do I have to make a new one? Well, I mean, it's right here. You don't have to remember. I could use I, right? Why can I use I? I'm not saying it's wrong. I'm just asking why I could use I. Well, I doesn't tell me that. I will have a value, right? So what are we using I for here? Help me out, you all. We're using for our loop counter variable, right? So it will have some value. So you're correct. I'm just trying to get us to, I'm trying to get you enunciate it. You're saying the right thing. You're not using the right words. So we're using this for our loop counter variable. It will have some value. Right, so let's put this I right here. We know this is going to have some value, and we know every time this loop iterates, I is going to have a different value. Right, so how do we control those values? We get to control what I looks like. We get to control what these values are every time it iterates. How do we do that? So we can set it to start at 1. And then here, what do? I want to make sure it runs 10 times, but I want I to have all of those values between 1 and 10. Okay, we could do less than or equal to 10, or we could do just less than 11, right? So there's a reason why that is just a little bit better than this. This is correct. This will do what we want it to do, but this will actually do two things. This is actually two separate operations. And what the computer will do, it'll check to see if it's less than that, and it'll check to see if it's equal to that. So that's kind of, for this, it's not such a big deal. But if this were, let's say if this loop were iterating, 1 million times, that's 2 million comparisons that you're going to run. You're doing twice as many. So, but that is correct. That would work. That would work just fine. So here, this will guarantee that I has all the values between 1 and 10, because we're going to increase by 1 every time, and we're going to stop when it equals 11, because that's going to be false. And if we compile this and run it now, what should we get? We should get the first 10 Fibonacci terms, and then I guess we could do something here. Very good. All right, and with that, we are out of time. Do you all have any questions for me? If not, have a good spring break, everyone. After spring break, we will start on while loops.